So one thing I would try to do is maybe like, I know if I can rationalize the denominator here, that can create the difference of two squares. What am I doing? All right, so if I do that, I'm going to have a, let's just write a tangent of x times a secant of x minus 1. And then over here, I'm going to have a secant squared of x minus 1. Now, again, remember, we have the we have sine squared of x plus cosine squared of x is equal to 1, right? So if you were to divide by everything by cosine, you would have a tangent squared of x plus 1 equals a secant squared of x. So subtract 1, subtract 1. Tangent squared of x is equal to a secant squared of x minus 1. So what is secant squared of x equal to? Tangent, right? Okay, that's good. So now I have a tangent of x times a secant of x minus 1 all over a tangent squared of x. Well, now, see that the tangent of x and the square, those are going to divide out. And now let's go ahead and write everything in terms of sines and cosines. So secant is 1 over a cosine of x minus 1 all over a sine of x all over a cosine of x. Now, if I want to get rid of this sine of x over cosine of x in my denominator, what I'm going to do is multiply by the reciprocal. So I'll multiply by cosine of x over a sine of x, cosine of x over a sine of x. Okay, make sure you just multiply it by times both things. Now again here, what that's going to do is that's going to divide out. Cosine of x times sine of x over 1 over cosine of x is going to be 1 over a sine of x, which is cosecant. And then cosine of x over sine of x is going to be over to a, it's a cotangent of x. Shoot, let me just write it like that, which is a cosine of x over sine of x, which you can see is exactly what we have here on the right-hand side. So it's now verified.